recording? Good. Okay. So our learning goals are to find the domain range of relationships. Okay? The domain of a function is the set of all valid x values listed from least to greatest, or leftmost to rightmost. Okay? And the range of a function is a set of all y values listed from the least to greatest, lowest to highest. Okay? Remember, x's are found on the x-axis, and the corresponding y's are the graph. Okay, so keep that in mind as well. Okay. So make a graph of this function, and this function is just a list of points. So it's just discrete points that we plot. Okay. So negative 3, 3, for instance, would be right here. And negative 2, 3, right here. Remember, x comes first and y comes second. Negative 1, 1 would be right there. 0 and negative 1 here. 2 and negative 4 down here. And 4 and 0 over here. Okay, so that's our function. It's just a bunch of points, not joined, just a bunch of points. So because they're just points and there's no joining involved, we're just talking about integers. We can write out the elements of the domain. So we can actually write out the numbers in the domain from smallest to biggest. So if you're looking at the x-axis here, let's kind of color it. As you're moving from left to right along the x-axis, what's the first value of x that has a corresponding point somewhere? So you're moving from way up here. The first time there's a point on the graph is when x is negative 3. Does everyone see that? Okay. As you're moving from left to right, so negative 3 is the first value of the domain. And then I keep moving. The next value in the domain is negative 2, because there's a corresponding point, y value of negative 2. And then I'm moving, and there's one at negative 1. There's one at 0. Is there one at 1? No. So we don't put 1 down. Is there one at 2? Yes. And is there one at 3? No. Is there one at 4? Yes. Okay, so there's my domain, listed from smallest to biggest. Okay, you can actually list them out. My range goes from lowest to highest. So I imagine starting down here at negative infinity and coming up. And the first time I touch the graph is at a y value of negative 1, 2, 3, 4. Negative 4. It's the least y value. Then moving up to negative 3, nothing. Negative 2, nothing. Negative 1 would be the next. Zero. Yep, there's a point there. Keep moving up. 1, yep. 2, nothing, and then 3 is in the range. That's our highest value in the range. So there's our domain and our range listed out explicitly. Okay? So this is all of the values in the domain from lowest to highest, all the values in the range from lowest to highest. Okay? Would this be a function?
Yeah.
Yes? Passes the vertical line test. Awesome. Okay? Examine each relationship given in various formats. State the domain and range of each relationship. Describe which relationships are functions and which are not. Okay. So this one is still a series of points, so I can still list my domain out. Agreed? So let's do that. I have these little lines here to help me. I don't know if I'll need my mouse or not to use them. Yep. Well, I don't know. We'll see. If I go to the pointer, I might not. Okay, yeah. Okay, so starting way out here at negative infinity, the first time I hit a point on the graph is at an x value of -3. Do you see that's the x value? Okay, so the smallest x value in my domain is -3. Then -2. The next smallest one. Then -1. You see here it makes it not a function at -1 because it goes through 2 points. Okay. So we've got -2 and -1. That's my arrow. 0, 1, 2, 3, and 4. They all have a corresponding. So there's my domain. And I'll just arrow and get this off. My range is all the y values from lowest to highest. So I'm starting way down at negative infinity. Coming up, the first time I hit the graph is at a y value of -2. The next one is at 0. Then at 1. Then at 4. Does everyone see that? Okay, so my range is going to be -2, 0, 1, and 4. From lowest to highest. Okay? So I've often, when I was first learning this, I used my pencil going across and from the bottom to help me. Okay? If you're a visual learner, that should help you. Okay, these are the arrows on the ends now. All right, so notice how this graph is connected. So all of a sudden I can't list out everything. I'm going to have to use that set builder notation. Okay? So let's imagine our domain here. Capital D for domain. Now this arrow here means that way over here at negative infinity, I'm going to be way up here at positive infinity. Everyone agree? So I'm still going to be on the graph. Always on the graph, 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 always on the graph. I'm never not on the graph. So my domain is all real numbers, which you just write as x is an element of the reals, but you don't need as long x because any real number is in the set. Any real number is in the domain. Okay? Range. Okay, so down at a little, oh, I put the pointer, no? Put the pointer again. Yeah, there we go. Okay, so I'm way down at negative infinity. Everybody good? Not up, I'm not on the graph, not on the graph, not on the graph, not on the graph until I hit -3. And then above -3, I'm always on the graph, always on the graph, always on the graph, always on the graph. Always on the graph because those arrows mean that I always go up forever. Okay, I'm just going to fix this so that the arrows are in the right spots. I think I click on this and then I want to that helps. All right, so how do I say that again? So my range is all real numbers as long as, so I can't be below -3. So all my x values have to be greater than or equal to -3. Oh, they're y values, my bad. First one and I screwed up. So obviously for range, we're talking about y values, so we use y instead of x. So my y values have to be greater than or equal to -3. So that's an important little thing to write down. Domain is always x, and range is always y. Okay. Domain is a set of all x values from smallest to biggest. Range is a set of all y values from smallest to biggest. All right, the next one. Oh, we didn't say whether it was a function or not. Is this one a function? Yes. It is a function. It passes the vertical line test. Is C a function? No, not a function. And it's connected, so we know we've got real numbers. And we know they're going to be bounded. So let's think it through how they're bounded. So way at negative infinity, I'm not on the graph, not on the graph, not on the graph until I hit -2. Then I'm on the graph always after -2 until I hit +2. And then I'm not on the graph again. Okay? So I want all real numbers between and including -2 and +2. So I'm bounded. So that means I'm going to have -2 and then 2 is my boundaries, x in the middle, and -2 and 2 are included, so I have less than or equal to signs. I face the window. Okay? So again, that says if I'm in this set, my x values are greater than or equal to -2 and less than or equal to 2. Okay? Now I'm going to do my range, so I'm talking about y values. And it's connected, so I'm using real numbers. So way down at negative infinity, I'm not on the graph. I don't touch the graph until I hit -5 for the range, and then I'm always on it, always on it, always on it, always on it, always on it until I hit +5. And then after +5, I'm not on them again. So again, my range is bounded between -5 and 5. Okay? So -5 would be my smallest, less than or equal to y. Make sure you put a y there because we're talking about range, less than or equal to 5. Okay. Next one. So when they give you an equation, it must be something you know how to draw. So it has to be a line, parabola, or circle. Okay? So which one's this? Line, parabola, or circle? Yep. Parabola. Excellent. Because y has a power of 1 and x has a power of 2. Okay, so you're just going to do a rough sketch. So this parabola has a vertex at 0 and -1. A different color here. And it's positive, so it opens upward. That's all you need to know is how low down it goes and whether it opens up or down. Okay? Or how far up it starts and whether it opens up or down. That's all you need to know in order to get the domain and range. Okay? All right, so is it a function? Yep. All right, so way over here at negative infinity, this arrow means I'm going to be on the graph. I'm going to be way up in the sky, but I'm going to be on the graph. Always on the graph, always on the graph, always on the graph, always on the graph, always on the graph. Okay? So that means that my domain is going to be all real numbers, and you don't need any as long as, just all real numbers. Okay? My range down here, I'm not touching the graph at negative infinity. I don't touch the graph until I hit -1. But after -1, I'm always going to be on the graph. So I want to be able to write all numbers greater than or equal to -1. Okay? All numbers greater than or equal to -1. So as long as, because we're not bounded on two sides, we start with y. We say exactly what we want to, greater than or equal to -1. Okay, E, make it look like yours, so you start with a point here. Just of those half parabola on its side type pictures. Is it a function? Passive vertical line test? Yes. So it is a function. Okay. So way over here at negative infinity, I'm not on the graph. I don't touch the graph until I have an x value of -3. And then after -3, I'm always on the graph forever. Okay? So I want all real numbers that are greater than or equal to -3. All x's that are greater than or equal to -3. See if you can figure the range out. Okay, so down here, you're not on the graph. Don't touch it until a y value of -2. And then that arrow means you're going to always be on it. Even though you're going up at a slow rate, you're always going to be on the graph after that. Okay? So who thinks they've got the range in Seinfeld notation? Or who wants to try it? Yep.
So why, can't remember what the E means.
Is an element of?
Element of real numbers.
Yep.
Slash.
As long as?
As
Yep.
long as y is greater than or equal to -2.
Perfect. Okay, how many people got that? Wow, that's awesome. This is a tough topic. We're just starting to learn. That's great. Okay, the next one, we're given an equation again, so it must be something we know how to draw. So it's either a line, a parabola, or a circle. So because y has an exponent of 1 and x has an exponent of 2, it's a parabola. What's the vertex of the parabola? +3, +5. Okay, so if you're rusty, it's the opposite number in the brackets with the x for the x, and the same for the number outside for the y. Okay? So the vertex, say it's HK, but so it's got the opposite sign for the x and the same sign for the y. So 3, 5, so just pick a spot, and that's going to be 3 here and 5 here. And then the negative out front means it's opening downward. That's all we need to know, okay, to get the domain and range right. So we just have to draw a parabola that's opening downward. Just do a sketch here. The arrow's on the end, so we know it goes on forever downward. Okay, so it doesn't have to be anything fancy, just you got to know where the vertex is and whether it opens up or opens down. Okay? All right, so is it a function, first of all? Yes? So our domain, so at negative infinity, because of those arrows, I'm on the graph, on the graph, on the graph, always on the graph, no matter what. So that's just, to be in a set, you just have to be a real number, that's it. Every real number is the domain. Range, see if you can reason through what the range would be. Okay, so I'm thinking of it way down here. I am on the graph because these arrows mean they go down forever. So I'm always on the graph, always on the graph, always on the graph, up to 5, but then after 5, I'm not on the graph anymore. Okay? So anyone think they know how to write that? Is this up? Yeah, Eva? Yep. Yes, good. How many people got that one? Good. Arrow pointing the right way? Very good, very good. Okay, the next one's a line. Lines have pretty simple domains and ranges. First of all, it's a function. So if we think about it, the arrows going up and downward mean I'm always on the graph. So way at negative infinity, I'm on it. Always on it, always on it, always on it. Okay, so every real number is in the domain. And then for the range, I've also got arrows pointing downward forever and upward forever, right? So for range, I'm always on the graph. Oops, undo. I'm always, I don't know, why is it doing that? I can do it with my mouse. Way down at negative, no, I can't. Okay. There we go. So I'm always on the graph, always on the graph, always on the graph forever. So my range should be all real numbers as well, except you have to use a y. Okay, this one is interesting. But we're almost at break time, and I want to spend time discussing it, so you just have an extra 2 minutes of break time. So let's start by my copy. Fine, so I'm going to pause this. So enjoy your break. Okay. Okay, so I have to draw in, you guys have these little dotted lines here that I need to add here. So this dotted line is along the x-axis, the y-axis, sorry, which has the equation x equals 0. And this dotted line is along the x-axis, which has the equation y equals 0. And then these curves have arrows on the ends of them. Okay, so what are these dotted lines? They're called asymptotes.
Lady arrived yesterday. I think it was sort of unplanned, or at least maybe not unplanned.
Sorry, Jada. That was nice. It was Apple News, something. Okay? Don't know what that was. All right, asymptotes. An asymptote is an invisible line that a curve can get infinitely close to, but never touch or cross. So that's our definition of an asymptote, an invisible line that a curve can get infinitely close to but never touch or cross. And it is part of the graph, okay? Even though it's invisible, it's part of the graph. You have to put it on. And they have equations because they're vertical or horizontal lines. So all vertical lines have equation x equals, and all horizontal lines have equation y equals. Okay, wherever the asymptote happens to be, and they don't have to be on 0 all the time. Okay, so with that in mind, first of all, let's do our vertical line test and see whether we think it's a function or not. So that arrow, this going this way means I would be on the graph. Everyone agree? Always on the graph, always on the graph, always on the graph, but just once, right? Never failing the vertical line test. Here I'm not on the graph, but then as soon as I get to this side, I'm on the graph again, but only in one spot. No. Okay. Nope. Okay. Gonna pick it up here. That is like, why is this happening? I don't know. All right. Yeah, I don't know what to say. All right. That's really weird. Okay, so our domain is all real numbers as long as. So first of all, we decided it was a function. It was a function because we never failed the vertical line test. Okay. And if you remember my green line going across, we were always on the graph except at 0. Okay? And we know how to write that set. Every real number except 0 looks like that. Okay? I'll check and see if I can lift this red line up. No, I have no idea why. Okay, so not on the graph, not on the graph. Until I hit, always on the graph, always on the graph, always on the graph, always on the graph, until I hit 0 again, and then as soon as I get to the other side of 0, always on the graph forever. So every real number except 0 again, but this time I have to use y value. I have no idea what is happening. It's annoying. All right, this one. So you guys try this one. See if you decide whether it's a function or not, then just figure out the domain and the range. Okay. What do we say? Is it a function? No, very good. I can put my vertical line here. You can see it touches in more than one spot. Everybody good? But I can't put it there for some serious reason. And then what would my domain be? To think, say about the domain. Yep.
X can be any real number.
Yep.
That is greater than or equal to -3.
Perfect. Check and see if you got your arrow pointing the right way. Yes? Okay. Range. Anyone think they've got the range? Yeah. Just that. Any real number. So these are going to spread out until all the way from negative infinity to positive infinity. Okay? Okay, this one I really want to be able to use the lines, so I'm going to have to make new lines if it won't let me use these ones. It won't, so insert line, and I want to make it green. Click on it. Look, it won't, it'll let me make it, but I can't use it. What?
Because you clicked lock and
No, but I didn't, it was working. View. Format, lock. That's, but it won't let me. No. So I can just keep making lines, but I can't use them?
exactly.
That's not fair. That's not what a smartboard's supposed to do. It's, the shadows don't work. Oh, this is super annoying. What if I bring one from another page that works? Do any of them work now? None of them work anymore. This is so upsetting. How's Jada gonna see it? That's not okay. Do you know how long it took me to put those lines there? I did it for every question. Oh, okay. There's that vertical line. Everyone agree? Vertical line test? Yes. Do we agree it passes the vertical line test? Yes. Oh. I'm glad this is my grade 11 class and not my 9th thing. He asked me for a different teacher. Okay. Domain. All right, so way over here is my green line. Imagine it. This arrow means I'm on the graph. Way over here, right? And I'm always on the graph, always on the graph, always on the graph, always on the graph, even at 0. But do you see between 0 and 1, I'm not on the graph? I'm not on the graph between 0 and 1. And then all of a sudden at 1, I start being on the graph again. So that's 2 different sets. I'm going to have to use a union here. Okay, because there's a gap in x values. I'm always on the graph, until just after 1, and then between here and here, I'm not on the graph at all. There's a gap. Okay? So the way I'm going to write that is using union. So I've got my first set is all real numbers as long as they're less than or equal to 0. Union, all real numbers as long as they're greater than or equal to 1. Okay? Okay, now, everybody good on that one? So that's a thinker. Because of the gap, we have to use a union. So we have all of these, we're always on the graph, until right in between those two. And then there's no corresponding y value to any of those x values in there. Okay? Now imagine the range. So we're starting way down here. Okay, my arm's the line. We're moving up. We're on the graph though, because of that arrow. Everyone agree? So we're on the graph. Even here where I'm concerned about, I'm on the graph. Everyone agree? All the way up until here. And then after that, I'm not on the graph. Okay, so we need one set for this one, because I was always on the graph until I got above 3. Okay? I was always on the graph until I was above 3 for the range. So that's going to be all real numbers as long as they are less than or equal to 3. So this would be my concerning part, but I am on the graph there, okay? The gap is only with the x, it's not with the y, right? All right, here's another one. First of all, we're going to move our green line along and decide whether it's a function or not. So does it pass the vertical line test? Where would be concerning? Right here. Does everyone agree? There could potentially be 2 points here along their line. But if one's a hole and one's not, there's really only 1 point there. So because that's a hole, that's not really a point. That one is, we've still only got 1 point there. And that would be our only spot we worry about. Everywhere else, there's only one. Okay? So this is a function. We've got an arrow here, and that's our only arrow. So imagine your domain, see if you can figure out what it would be. So use your pencil, go all the way from left to right, so you can see what numbers would be in it. And then if you can kind of describe what those numbers look like in your head, usually you can translate them. Does anyone think they know the domain?
Any real number that's less than -3, or greater than -3.
Greater than -3. Very good. Okay, now watch the thinking here. Not on the graph, not on the graph, not on the graph. -3, I'm not on the graph, but as soon as I get to -2.999, I'm on the graph. And then after that, I'm always on the graph. Here would be my only worried spot, but I am on the graph, and then this arrow means I'm always on the graph after that. Okay, so I only need one set for my domain. My range, so I really want to use my red line, but I can't. My range, so imagine me coming up from the bottom. I'm not on the graph, I'm not on the graph, I'm not on the graph. At -1, I'm on the graph. Everyone agree? Not on the graph, not on the graph, not on the graph. 2, I'm on the graph. So there's only 2 values in my range, -1 and 2. So I could list them. Can I not? In order from smallest to biggest. There's only 2 values in my range, -1 and 2. Okay? All right, so you're gonna do a practice and do it